The last continuous probability distribution we're going to discuss in this chapter is uniform. With continuous uniform probability distribution, the probability of any interval in the distribution is equal to any other interval with the same width. So here is the formula for the density function. We're going to actually be looking at the formula if we want to find the probability of a value. So remember, when you're trying to find the probability of a range of values, you would have a number here and a number here. But when you're trying to find the probability, you're going to have an upper endpoint and a lower endpoint for that data because it is going to be a uniform distribution, and I'll show you a picture in a second, but it has to have a lower and an upper endpoint because it is an interval. And I do need to say about A and B. A is the smallest allowable continuous random variable, and B is the largest allowable. So this will be given to you in the problem. And so the best thing to do is really just look at one. So here's what a uniform looks like. Okay. The highest possible value is 155 for this interval, and the lowest is 55. So those are your A and your B. Okay. And then your area under your distribution is still going to be 1. Okay, this would be x and x1 and x2, and then we would plug that into the formula. So if you plug this into the formula, you have here is A and here is B. So that's the maximum and minimum values in this distribution. And we're looking for the probability that x is in between 70 and 90. So this is going to be, these are going to be your x values. So you're going to take your highest x minus your lowest x, and it's going to be on the top. And then down on the bottom is your maximum amount, which is B minus A. Remember, it is x2 minus x1 over b minus a. So let me label this a little bit better. This would be x1 and x2. And this is a and b. And so if you plug that into your formula, you will get your probability of it being 0.20. Okay, and here's how you would find the mean and the standard deviation. So you will have to be careful and understand that A and B are the absolute maximum and minimum values in the distribution, where it says the lower endpoint and the higher endpoint of the interval of interest. Okay, so the first problem we're going to look at, let me go back to question 1. And it looks like we're doing a uniform distribution between 10 and 30. So if this was a uniform distribution, or since this is a uniform distribution, my entire distribution is from 10 to 30. So A is my smallest allowable random variable, and B is my largest allowable random variable for this distribution. So A and B are not going to change. They're going to be 10 and 30 in this problem. But first, we're going to look for x is less than or equal to 15. Alright, so what we're looking at here is, let's say 15 is, I'm just going to pick a place to put 15. So we want it to be less than or equal. So A and B, we can go ahead and label. Now, we want to know the probability that it's less than or equal to 15, but it can't go below the 10. So now we can see that technically we want to know the probability that X is between 10 and 15. So this is X and X, X2 and X1. So we're going to plug it into our formula, which is 15 minus 10, X2 minus X1, over B minus A, which is 30 minus 10. And we're going to get 5 over 20, which is 1/4, which is 0.25. So that is our probability that X is less than or equal to 15. Now let's look at 20. This time we're going to change X2. Now X2 is going to be 20, which would be a little bit further up. I'm just estimating. So now X2 is going to be 20, and we want it to be less than or equal. So we're basically saying the probability that X is less than 20, the probability that X is in between 10 and 20. So we just plug it into our formula. X2 is 20 minus X1 is 10 over B minus A. So that would be 10 over 20, which is 0.5. So the probability that X would fall within that range is 0.5. Less than or equal to 25. So all that would change is X2 is now 25. So we would do the probability that X is in between 25 and 10, because it can't go lower than 10 in this particular distribution. So 25 minus 10 over 30 minus 10 would be 15 over 20, which is 3/4, which would be 0.75. Okay, so going back to our continuous distribution, the last part, well, getting to the last part, the probability that X is equal to 26. This is a continuous random variable. This is just like we discussed earlier. The probability of it equaling one value in a continuous random value is going to be so close to 0 that the probability is basically 0. Now the mean and the standard deviation. So the formula for the mean and the standard deviation, I'm going to copy that formula over and erase some of this. So it's A plus B divided by 2. So it's basically your, I'm going to move this up so we can see it. So it's basically an average of A and B. So your mean here is A plus B divided by 2. So 30, 10 plus 30 divided by 2, which would be 20. Now your standard deviation here is B minus A which is 30 minus 10, and it's always divided by the square root of 12, which is kind of strange, but that is the formula. So you get 5.77, we'll round to 2 decimal places, unless they tell us otherwise. Yeah, 2 decimal places, so 5.77. So in this problem, we have a continuous uniform distribution between 70 and 95. So 70 and 95 are A and B. And for the first problem, it asks the probability that X is greater than 78. So 78, let's just say it's right here somewhere. And I should have did that in purple. So we want it to be greater than 78, but it has to not go past the distribution. So now we can see that this is x1 and this is x2. Alright, so now we're ready to plug in the probability that x is in between 95 and 78. So we're going to say 95 minus 78 over 95 minus 70. And you will get 0.68. So for these, you don't have to use the complement rule. It will give you your answer for greater than by using that interval. Okay, so x equals 77. It can't equal at one number. The probability would be close to 0, so the answer is 0. I showed you how to do the mean and the standard deviation using the formula.